Okay, now let's check another example. Let's draw the structure of methane. CH4. Carbon atom is tetravalent. 1 carbon, 2 electron, 3, 4. How many hydrogen atoms is there? 4. Let's go. 1 hydrogen, 2, 3, and 4. So ability of carbon to form valence electron is called tetravalency. In this place, carbon links with oxygen to form carbonic compound, carbonic group. Now, carbon links with OH here to form hydroxy group, which is called the alcohol group. This CO group is called carbonic group. I do know. Are you getting it now? This is carbonic group, or it can also be called keto group. Keto group. That is what tetravalency is talking about. Carbon linked with electronegative elements such as hydrogen, nitrogen, oxygen, and the halogens. You know, I told you what this is. The halogens is talking about X. Chlorine, bromine, and iodine. They are the group 7 elements. So carbon is very unique to an extent that it links with some elements that are electronegative. Although hydrogen is electropositive too. Okay, now let's check. Yeah, carbon links with hydrogen here. It can form methane gas. Sorry? This is methane. Can you say something? See, hydrogen is very unique. It can link with 3 atoms of hydrogen to form methyl. 4 atoms of hydrogen with carbon form methane, which is an alkane family. This one belongs to alkyls group. This one belongs to the alkanes, which is the paraffin. Do you understand? So what I'm trying to talk about is that carbon is unique. It has the ability to link with some elements like hydrogen, nitrogen, oxygen, and halogens. So carbon linking with hydrogen can form a methane gas. Carbon links with hydrogen, 3 atoms of hydrogen forms what? Methyl group. Now, for number 2, it links with nitrogen. Carbon links with nitrogen. Can you something? It links with what? Nitrogen, forming triple bonds. If carbon links with nitrogen, it forms cyanide. The cyanide, cyano. Like what happened here? NH4, CNO. So that's what really happened there. So let's check it out. Hydrogen links with, how many hydrogen atoms do you have here? Can you see something? Linking with cyanide. Are you there? So this is what really happens here. Now, linking with what? Oxygen. If it links with oxygen, it's forming CO. This CO is said to be carbon monoxide. Carbon what? Monoxide. If it links with CO2, that's carbon what? Carbon 4 oxide. So it's forming an oxide of carbon. Although whenever you see CO in organic chemistry, it's not called carbon monoxide, it's called carbonyl. Carbonic group. Carbonic groups. And or you can also call it the keto what? Keto groups. Carbon can link with electronegative elements, linking with an hydrogen forming methane, methyl, linked with ammonia, linking with nitrogen, it forms cyano group. Linking with oxygen, it forming keto group. And CO can be carbon monoxide, carbon monoxide, CO2 can be what? Carbon 4 oxide. That's one uniqueness of carbon. If it links with halogens, it's going to form what is called the halides. The halides. The halides, like, if it links with, this is chloro. Chloro depends on the number of carbon. If it is 1 carbon, is what? Chloromethane. If it links with 2 carbon, CCl2, it will be dichloromethane. They are the halides. If it links with bromine, it's going to be what? Bromoalkane. But if it is only one carbon that links with bromine, it's called bromomethane. If there are two bromine, that's when you're going to have a dibromomethane. Why are we saying methane? Methane has only one carbon. Do you understand? So the last uniqueness is carbon forming what? Ability of carbon to form a single bond, double bond, and the triple bonds. Triple what? Bonds. Carbons form single bond, double bond, and triple bonds. In this place, carbon can link with this. This is a single bond. And if carbon has a single bond, it is called, belongs to the alkanes. Carbon forming a double bond here. This is a double bond. Belongs to what now? The alkanes. Whenever you see double bond, it's called hene. Whenever you see single bond, it's called hene. The suffix "ane". Alkane. Double bond "ane". Alkane. If it has a triple bond here, it's alkyne, which is what? Ine. So that is the reason why carbon is unique. A single bond, double bond, and the triple bonds. The triple what? Bonds. So if carbon atom hold a single bond, is alkane. If carbon atoms hold double bond, is said to be alkanes, which is ene. If carbon atoms hold triple bond, is ine, which is the alkynes. So that is the uniqueness of carbon. Ability of carbon to form single bond, double bond, and the triple bond. Now let's look at the properties of organic compound. Properties of organic compound. You know, we need to know the properties of organic compound because we have an inorganic compound also. Number one is that, they are covalent compound. That is, the bond that exists in them is what? In them is covalent what? Bond. Take note. All organic compounds are covalent compound. The bond that exists in organic compound is what? A covalent bond. Due to the covalent bonds, due to the covalent nature, they are non-what? Conductor of what? Electricity. Non-conductor of what? Electricity. Hence, they are non-electrolyte. Non-electrolyte. They cannot conduct electricity because they don't have unlike charge of electrons. So they are covalent compound. The bonds that exist in them is a covalent bond, and that's due to the covalent nature. They are non-conductor of electricity, and they are non-electrolyte. Non-what? Electrolyte. Non-electrolyte is in that they cannot conduct electricity in molten state or in solution. They are what? Insoluble in polar solvent, e.g. water. So you cannot expect organic compound to dissolve in water. They're insoluble in water. For example now, kerosene is an hydrocarbon. Let's use fatty acids. A fatty acid is like, let's use oleic acid. Oleic acid, an example from olive oil. Oleic acid from olive oil and dissolve oleic acid inside water. You observe that oleic acid will not dissolve in water. It shows that oleic acid is insoluble in water. Are you there? And it shows that oleic acid is what? Non-polar. Non-polar. We should know that oleic acid is a fatty acid and it's called unsaturated fatty acids. It's classified into what? The unsaturated what? Fatty acid, and it's gotten from plants. So almost all plants fatty acids are what? Unsaturated, and they are very good. Unlike saturated fatty acid, like stearic acid. The stearic acid, we have the palmitic acid. All these are examples of organic compounds. They cannot dissolve in water. So they are insoluble in water. Okay. Number 2, they are soluble in non-polar solvent. Non-polar solvent. E.g., ether, benzene, toluene, etc. Yes, you can dissolve that stearic acid, that oleic acid, palmitic acid, capric acid, or all fat and oil. You can dissolve them inside. You can dissolve them inside non-polar solvent. That shows that they are soluble in non-polar solvents because non-polar plus non-polar dissolve. You can dissolve kerosene inside petrol. Kerosene is non-polar. Petrol is non-polar. So they dissolve. So polar plus polar dissolve. For example, we can dissolve water inside ethanol. We all know what ethanol is now. Ogogoro. We can dissolve ethanol inside water. It will dissolve. But ethanol is organic compound now. What makes ethanol to dissolve in water? The reason is that ethanol has the formula of what? C2H5OH. It can also be called ethyl alcohol. The reason is that it's so simple. Ethanol have a functional group called hydroxy group. Hydroxy what? Hydroxy group, which form an hydrogen bond with water. So it is because of the functional group, which is the hydroxy group, links with what? The hydrogen found in water to form an hydrogen bonding. So that's what brings about the solubility of ethanol with water. Number 3, organic reactions are very slow. They are very slow. They need what? They need catalysts. Catalysts to what? To speed the reaction. Let's look at addition reaction of unsaturated hydrocarbon. This guy is 18 plus, if you react with an hydrogen gas, you will get C2H6. Are you getting it? Yeah, this guy is what? 18. This guy is 18 is what? An unsaturated what? Hydrocarbon. Why this guy is what? Saturated. This reaction is extremely what? Slow. For the reaction to be fast, you put a catalyst in it. You can put a catalyst like nickel catalyst. Nickel catalyst will speed the reaction. You understand? So this reaction is called hydrogenation reaction or addition reaction. So all reaction involving organic chemistry, organic compound are very slow. Look at this reaction. Arrow and what? Arrow, you go get wrinkle, you go get water. Yay! What's this reaction? This reaction is called esterification. This guy is an alcohol plus what? Carboxylic acid. You go get ester and water straight up. This reaction is called esterification. This reaction will be very slow except you put a catalyst in it. The catalyst we put in this is called H2 tetraoxosulfate 6 acid, which you call the sulfuric acid. If you don't put this catalyst, the reaction will be what? Will be slow.